What about this one? I'm a /16. We're now a /26. Is that even possible? Is that even possible? I'm a /16. Now I am a 26. Can we even do that? You bet we can. You bet we can. How many bits did we borrow? Yeah, we borrowed 10 bits. 26 minus 16. You might be saying, whoa, hey, hang on there, Raymond. Back up just a second. Are you telling me that this orange boundary line here is not stopping the Class B address from continuing on down? No, not at all. Not at all. You see, according to Class B, there's no such thing as Class C. No, not at all. So you can break through that and you can keep going. So if I'm a 16, I can go to 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. No problem. No problem. That orange Class C default, that doesn't get in the way. Doesn't change anything. Doesn't impact my Class B. I just keep going. So as you can see, I can go down to a /30. And how many bits did we borrow? Let's try that again. $14 bits. That's right. 14 bits. No problem. All right. Let's go back to the top. Class A. Class A. /8. Let's go to a /12. How many bits were borrowed? Easy. 4. Does the Class B address get in the way? Nope. Let's say we go to a /17. How many bits did we borrow? 9. Does the Class C get in the way? Nope. How many bits did we borrow? Whoa. 18 in this case. So it's very important to know your starting point, so you can figure out the number of bits that you borrowed, because the number of bits you borrowed ultimately determine the number of subnets you're going to create. All right, so let me ask you this question now. We are a Class A. Boop. We have just turned the subnet mask into a /27. How many bits were borrowed? How many bits were borrowed? All right, so you know it's Class A. Starting. Now you know it's a /27, so it's 8 and 8 is 16. 19 bits were borrowed in total. We can see them there. So let me ask you this question. We are currently, right? New question, right? New question. So we are currently a /26. We are currently a /26. All right, we are currently a /26. How many bits were borrowed? How many bits were borrowed? Write it down on a piece of paper, chat it out, yell it out, let everybody know. Pick up the phone and tell your best friend. /26. How many bits were borrowed? Are you having trouble figuring that out? Right, remember I said it was simple math. So /26, I'm currently a /26. How many bits were borrowed? Did you say 2? 2's not the answer. Did you say 10? 10's not the answer. Did you say 18? 18's not the answer either. Why? Because I didn't tell you where to start, did I? Did I give you a starting point? No, I didn't. I didn't say where we started. As a result of that, if I just said you're a /16, if you don't know your starting point, you don't know how many bits you borrowed. Because if we started out as a C, how many bits were borrowed? 2. If we started out as a B, how many bits were borrowed? 10. If we started out as an A, how many bits were borrowed? 18. You see how it changes based on your starting point? And that means that the result of the number of bits you borrowed based on your starting address, class, is going to change the number of subnets that are created. So it's very important. Let me stress that one more time. You know the starting point. You have to know the starting point. You have to be able to figure it out. So for example, you could be told it's a Class A address. Then you know your starting point's /8. So then 26 minus 8 gives you a grand total of 18. You could have been told it's a Class B address. So then you know 26 minus 16. You could have been told it's a Class C address. Then you know it's 2 bits were borrowed. 26 minus 24. You could have been given an IP address. For example, your IP address right now is 190.3.8.5. Whoa. Well, what class of address is that? 190 is Class B. 190 is Class B. So you need to know that in order to figure out the number of bits that were borrowed. Very important.